Hey folks, I'm Chuck Black. We're doing 52 weeks of Python in 10-minute sessions. The topic for this week is, quote, everything is an object. You may have heard the phrase before where people say that in Python everything is an object. I'm going to explain to you what exactly that means and demonstrate to you a little bit about how the idea of mutability and immutability factor into that. So let's get started. Okay, so the first thing I want to say about this topic, everything is an object, is this. If you are a beginner and you're just starting to pick up Python, then I give you a hall pass, meaning I'm allowing you to not fully understand this. Go ahead and listen, and if you understand it, great. If you don't worry about it. I will have planted the seed in your mind so you'll have a general idea of what people are talking about when they say everything is an object. If you are an intermediate or advanced Python developer, you do want to understand this. So in order to understand what we mean when we say in Python everything is an object, we have to look at how programming languages worked in the past. In the past, variables that would be defining things like integers or floats or strings or whatever would be stored in memory, and the variable would just point to a location in memory. In higher level languages, you would end up having things called objects, and objects would have a value, which would be like this number that we would see here, or the string that we see here. They would also have a reference count, how many different variables are pointing at this. They would have a type like an integer or a float or a string, and they would have methods associated with it that you could perform functions on. A method is just a fancy name for a function. And that's the way that it was. Languages like Java have primitives as well as regular higher level objects. In Python, everything is an object. That means when you define something as simple as I equals 1, then that 1 becomes an object. The value is 1. The reference count is 1 at the beginning when I is pointing at it. The type will be integer. It will have these methods. Doesn't matter if it's a simple data structure like an integer or a string or a float, or if it is a list or a dictionary or even nested data. Everything is going to be an object. And so in Python, that's what we mean when we say everything is an object. So you may be asking, why is this important? And frankly, at the beginning of your life as a programmer, it's probably not very important at all. But as you move into the world of being intermediate, you can see we're in the intermediate phase here. Some of these things are actually more advanced than intermediate. Then you're going to begin to want to know about this type of thing. And it especially becomes important when we talk about mutable data types versus immutable data types. And I'm going to give you a taste of that now. If I were to say I equals 1, what would happen is that Python would create an object and have the value of that object be 1, and I as a variable name would point at it. If we then went forward and said j equals I, what Python is going to do is it's going to say, okay, j is going to point at the same object that I points to. So now you see j is pointing at this object that has the number 1 in it. And if you're keeping track, the reference count will have gone up. Now what happens if I come down and I say I equals I plus 1? What is Python going to do? And from this picture, you can see that this is what Python is going to do. It's going to create a whole new object. The value of the object is going to be the current value of I plus 1, so it's going to set it equal to 2. But the value of j, because it pointed at that object, is going to still be 1. That's because different data types have different types of mutability versus immutability. Immutable means it will never change. So an integer value doesn't ever get incremented. So if it was mutable, we would have just changed that number to 2 and j would have been equal to 2. But because integers are immutable, then j still points at 1 and I now points at this new object 2. So you can see immutable data types. Integers are immutable, strings are immutable, tuples, which we haven't gone over yet, but they're basically a list that can never change. Those are all immutable. Mutable data types, on the other hand, things like lists, you can append things to lists. We've done that. Dictionaries, you can add items with a new key to a dictionary. So those are mutable. So are sets, which we will talk about later on in our discussion of intermediate stuff. So everything is an object. It comes into play when we start to talk about mutable versus immutable. If you're brand new and you're thinking, whoa, is everything going to be confusing like this? No, it's not. We're going to be back to normal stuff soon. But if you are somebody who is really making an effort to learn in depth what all of Python and programming is all about, then this is going to be important. Next, I'll give you a glance at the code that I have created to demonstrate this. So I've written some code to demonstrate this exact thing, and the code is right here. Again, if you're new and you look at this and you say, is this what code is going to look like from now on? Absolutely not. But what I have done is I've written some code that basically does I plus 1. We do I equals I plus 1, then I do j equals I, then I do I equals I plus 1 after that. And if we look at the output then in detail, then you can see the differences. I do ID to show you what it's pointing at. There was a new object created when I added 1 to it. When I had I and j pointing at, when I had j point at I, then it's pointing at the same thing. When I incremented I by 1, then I is now pointing at a brand new object and j still points at the original one. And that is basically what this is showing you. And you can look at the long form of this, and I'll go through it in much slower detail. What I do also is I talk about the fact that if a list, which is mutable, and again, I'm going to be referencing two lists, L1 and L2, and then we're going to see as I go through this code in the other lesson, if you're interested, what happens when you add to it. You can see here this ID, meaning the memory location where the object is located. You'll see it never changes. So that may be of interest to you, that you can go and look at. The last thing that I do is even more detailed, and that is to look at the ramifications when we're calling functions. And I'm not going to go into that right now because this would be way too difficult. If you are interested, this is where mutability versus immutability pops up. If you do have a question, you can let me know on this after you've listened to the long form version of this code. Let's just review really quickly. Mutable versus immutable is important, and what did it mean when we said everything is an object? What we were talking about is this, that everything in Python is going to have its own value, which of course is similar to that, but it has all this other stuff associated with it. And of course, the ramifications of that come into play down here where we were talking about this. Hopefully that makes sense. Thanks for listening.